In 2026, military technology is evolving faster than ever, and one of the most talked about emerging systems in defense circles is the F-F missile. The name translates to dolphin, an animal known for intelligence, agility, and precision, and those traits perfectly reflect the philosophy behind this next-generation weapon concept. F isn't about brute force alone. It represents a shift towards smarter, more adaptable strike systems built for modern, complex battlefields. What makes F-interesting right away is how it fits into the new era of warfare, where information and timing can matter more than sheer explosive power. In the past, missiles were designed around a single mission profile: fly fast, hit hard, and that's it. But today's operational environments are crowded with electronic interference, layered air defenses, mobile targets, and real-time intelligence networks. F is associated with being designed from the ground up for this reality. One of the defining characteristics of the F concept is versatility. Rather than being limited to one type of target, it's often described as a multi-role precision missile. That means it could potentially engage land targets, maritime threats, or high-value infrastructure, depending on configuration. This flexibility reduces the need for multiple specialized missile types and gives commanders more options with fewer platforms. Aerodynamically, reflects modern low-visibility thinking. Its body shape is believed to emphasize reduced radar signature through smooth contours and careful surface design. While it may not be invisible, even a small reduction in radar detectability can shorten the reaction window for defense systems. In missile warfare, seconds matter. A delayed detection can be the difference between interception and impact. Materials technology also plays a big role in systems like Modern composites and heat-resistant materials allow missiles to handle higher speeds and greater stress without adding excessive weight. A lighter but stronger airframe improves range and maneuverability at the same time. It's a balancing act between durability, performance, and stealth characteristics. Speed is another area where F is associated with advanced capability. Instead of focusing on slow, easily tracked flight profiles, this missile concept fits into the high supersonic performance category. That speed reduces the time available for enemy response and complicates tracking solutions. But raw speed alone isn't enough. Predictability is what defense systems exploit. That's where maneuverability enters the picture. Late-stage maneuvering is a major trend in modern missile design, and is linked to this approach. The ability to change trajectory in the final phase of flight makes interception significantly harder. Many air defense systems are optimized to deal with threats following predictable arcs. A missile that can adjust direction at high speed forces those systems to constantly recalculate, increasing the chance of a defensive miss. Guidance technology is where the story becomes even more aligned with 2026 warfare trends. Traditional reliance on satellite navigation is risky in an era of electronic jamming. Modern missile concepts therefore use layered guidance. is associated with combining inertia navigation, satellite correction when available, and alternative methods such as terrain comparison or scene matching. By cross-checking multiple guidance sources, the missile maintains accuracy even when one signal is disrupted. On top of that, there's increasing discussion around onboard processing power. Missiles are no longer just guided projectiles, they're flying computers. Advanced processors can analyze incoming data, filter out interference, and refine targeting during flight. fits the narrative of intelligent munitions, where decision-making is partially automated inside the weapon itself, within pre-programmed parameters. Another major shift in modern warfare is network integration. F1/F is often described in the context of network-centric operations. Instead of being isolated after launch, the missile could potentially receive mid-course updates from external platforms such as aircraft, drones, ships, or ground command centers. This allows retargeting if the original objective moves or if new intelligence identifies a higher priority target. That level of connectivity transforms a missile from a one-time tool into a flexible, real-time asset. This also connects to the growing role of unmanned systems. Drones today act as forward sensors, identifying targets deep in contested zones. A missile like F1/F could theoretically be launched from a safer distance and guided using data provided by these unmanned scouts. The separation of sensor and shooter increases survivability for launch platforms while maintaining strike effectiveness. Electronic warfare resistance is another theme surrounding F1/F. Modern battlefields are saturated with jammers and decoys. To remain effective, missiles need hardened electronics, signal filtering, and the ability to function in degraded environments. F1/F design narrative suggests strong emphasis on resilience, ensuring that even in heavy interference, the missile stays on course. Range is always a critical factor, but in systems like F1/F, it's less about breaking records and more about operational flexibility. A balanced range allows launch platforms to operate outside the densest defensive zones while still reaching strategic targets. Combined with speed and low observability, this expands the safe operating envelope for aircraft or ships carrying the missile. Another interesting aspect is how modern missile systems focus on modularity. F1/F is often discussed as having potential for different mission packages or configurations. That could mean variations optimized for different target types, guidance enhancements, or electronic countermeasure features. Modular design shortens development cycles and allows continuous upgrades without redesigning the entire system. From a strategic standpoint, weapons like F1/F influence more than just tactical engagements. They affect deterrence. When a system is known for precision, adaptability, and resistance to countermeasures, it changes how opponents plan defenses. Even the possibility of such capability forces investment in new interception technologies and defensive strategies. At the same time, the rise of systems like F1/F reflects a broader shift away from massed, unguided firepower toward fewer, smarter munitions. Precision reduces collateral damage and increases mission efficiency. In modern doctrine, a single accurate strike can achieve what once required dozens of less precise weapons. It's also worth noting how development of advanced missiles drives innovation in other fields. Improvements in sensors, materials, propulsion, and computing often spill over into civilian technology sectors over time. High-performance composites, miniaturized electronics, and advanced control systems have applications far beyond the battlefield. Training and doctrine must evolve alongside these technologies. Operating networked, multi-role missiles requires coordination between different branches and platforms. Command systems must process and distribute information quickly enough to take advantage of real-time retargeting and sensor inputs. F1/F represents not just a piece of hardware, but part of a larger system of systems. Defensive technologies, of course, are evolving in response. Advanced radar, directed energy research, and improved interceptor missiles are all being developed to counter high-speed, maneuverable threats. This creates a continuous cycle of innovation between offensive and defensive capabilities. In the naval domain, a missile with F1/F described traits could significantly alter engagement dynamics. Ships rely heavily on layered defense, but reduced detection windows and unpredictable terminal maneuvers stress those systems. For land targets, mobility is key. Vehicles, launchers, or command posts that move frequently are harder to hit, making retargetable, networked missiles especially relevant. Air-launched variants would offer additional flexibility. Aircraft could carry such missiles at standoff distances, striking without entering the most dangerous air defense zones. This aligns with the broader trend of extending reach while minimizing platform risk. Cost is another factor shaping modern missile development. While advanced systems are more expensive per unit, their precision and mission effectiveness can reduce overall operational cost. Fewer weapons may be needed to achieve objectives, and the probability of mission success increases. Looking at the big picture, F degrees F1/2 F degrees symbolizes how missile technology in 2026 is less about singular performance extremes and more about balanced, integrated capability. Speed, stealth features, guidance intelligence, and network connectivity all combine into a system that's effective across a wide range of scenarios. As global security environments remain uncertain, technologies like this continue to draw attention from analysts and defense observers worldwide. Whether in deterrence roles, strategic planning, or technological competition, the ideas embodied by F degrees F1/2 degrees are shaping conversations about the future of precision strike. In the end, the story of F degrees F1/2 degrees isn't just about one missile. It's about a generation of smart, connected, and adaptable systems redefining how modern militaries think about range, accuracy, survivability, and information dominance. And as technology keeps advancing, the line between sensor, decision maker, and weapon continues to blur, making systems like F degrees F1/2 degrees a symbol of where warfare technology is heading next.